Got it. Okay, everyone, welcome to the Utah Microservices Meetup group. This is our second session, so it's cool to see a good bunch of people coming back and some new faces as well. Scott, you introduced yourself. Do you want to say anything about the doctrine of useful objects before we get into it?
No, I'm just here to listen in, see see what y'all's perspective is. Okay.
If you've got more color or flavor to add to whatever I say, please feel free. Of course, if anyone has questions or comments or experience with it, please do share. The kind of flow I want to go through is, it's basically like the ideas expressed in the doctrine of useful object, which is a page. I don't know if
you know, Ethan, I would say one thing on second thought.
Yeah.
The thing to realize, and I think this is very critical for Ruby devs and web developers in particular, because and I'm one and have a similar history. We come up through the world of software development always having had an object relational mapping tool like Active Record or something like that. The really hard thing to grasp, because it requires a challenge to our tribal identity, the hard thing to do is accept that most of what you've learned about OO is not OO in the least, and it's all ORM. It's all procedural programming happening within data models. And it just so happens you're using an object-oriented programming language. So even a nil is an object in Ruby. Everything's an object. It doesn't really mean OO. The most important thing to understand about OO, the one thing that you can understand about OO, is that objects are for representing behavior, not data, except when you're using an ORM. And then it's the dirty little thing that we have off in the corner, quarantined. We've got all this stuff that's supposed to be behavior, and you got to deal with data. You got to deal with data structures. The problem with coming up in life through ORMs is you've learned most of software development, especially OO, through the stuff that was supposed to be quarantined. That's not the healthy stuff. That's the kind of, this crap doesn't work in OO, but we got to do it anyway. Just keep it off the side, off in the corner, and accept the fact that it's there. When you really get your head around OO, you stop having things like Active Record. You'll start realizing things like fat model skinny controller was always wrong from a design fundamentals perspective, always from the moment it was uttered. So I think keep that in mind, because what you're going to see here is stuff that maybe you've never seen before. You might be questioning, why would I do that? And the answer is, look into yourselves and see if you come from an ORM background rather than an OO background. And for some folks, this may be your first introduction to OO. And I know there's a fallacy in there, the one true Scotsman's fallacy. This OO is better than that OO and all that crap. But honestly, if you do your homework and do some studying and look into OO text and design text, you'll find that none of this is an example of that fallacy. That's it, Ethan. Thanks.
Awesome. Thanks, Scott.
Yeah, so and good luck with the rest of your reading now that I've laid that on the table.
It's all good. That echoes my own experience as well. Like, I learned OO as you add a getter and setter to get the data out of something rather than just accessing it directly. But anyway, okay, so the flow tonight is ultimately, it ties back to Eventide, because you'll see the ideas, I'm not sharing the document, let me put it up. The ideas expressed in the doctrine of useful objects show up all over the place in the Eventide framework, like the framework itself, as well as when you use it, when you write code designed to use it. Important question, is this text big enough for people to see? No. Okay, let's go 2 more. Is that good? Okay, this will be fun because these will be narrow, but we'll make it work. That's good. And so, like, I don't know that the journey we're going to take through here is the same one that other people have had, but this kind of journey that we'll do here, just some simple code examples, I think will motivate why we do patterns that we do when we're doing Eventide or in useful objects in general. Like, the stuff we talk about here today is not specific to Eventide, it would help in anything. I've used the patterns in JavaScript and made the code better. So that's just kind of what we're doing. So I have some notes here that I'm just going to type from because last time I didn't do that. And if you were here last time, you know why I never posted that recording. But what I want to do is just a real contrived example where we're doing a purchase workflow. So think e-commerce. And we're going to have two classes for this. A purchase class that represents the flow of purchasing something, and a charge class that represents the act of actually like charging a payment gateway of some sort, whether that's like you're actually doing a credit card gateway or Stripe or PayPal kind of an integration. And so to purchase something, this purchase object needs to collaborate with the charge object. And so what we're going to see is like, how do we make purchase aware enough of charge to do the stuff, but still have flexibility, not be subject to changes when charge changes, et cetera. So you can see here, I've got these 9 different directories all with the same files. And with each step, we're going to refine the approach. And I'm going to start with like how I started doing this sort of thing. Hopefully not with a typo. So there's a typo. So you got it. All right.
Program it with you.
Yeah. Like I literally. Anyway, all right. So to Scott's point, objects are behaviors and ought to do one thing. And in Ruby, there's a nice thing that falls out if we call that one thing it does the call method. So this purchase class is going to have this call method. And I'm just going to put a puts in here real quick. Purchase, oh my gosh, same typo a second time before charging to represent that there's more to purchasing than just charging the credit card. And then I'll put another one afterwards to show after charging. And then, so if we need to charge, like a real naive approach to this might be, well, let's just make a new charge thing and then we'll call what it does. And of course, if you're going to do that, we would need access to the charge class.
Do you mind maybe moving that picture out of me?
Oh.
Maybe the bottom right corner or something.
Oh no.
Or I guess
That is a Lake Powell thing, not a my computer thing.
maybe it's okay. I can do it.
Shoot.
All that's under there is just a text, right? It's like
Yeah.
or charging or something.
If meaningful code ever gets hidden by that, please do call it out again. I don't know how to change that thing's location. It's not evident from the controls here. Maybe camera control? Not cam control. That's an LVT joke, sorry. Yes,
Sorry
okay.
to interrupt.
No, you're good. Okay, so we'll put this charge class in here. And I am ignoring the like parameters at the time you do the charge. Like I'm ignoring the credit card number, the amount, product, all that kind of stuff. Because that isn't relevant to the actual point where we get how the objects collaborate with one another.
I think you know the class.
I sure did.
Charge.
I sure did, thank you. The wisdom of the crowd. I don't say that at all facetiously. And then in here I'll just put charged, meaning that we charged it. And then over here we'll put a file that uses this. So require rel hid again, purchase, and then let's make a new purchase. Hard-coded purchase.new, and then we can actuate. So when you call a method call in Ruby, you can invoke it on whatever it's defined on by just doing dot parentheses. Good luck Googling that. It took me a while to figure that out. But yeah, all right, let's run it real quick. So Ruby 01 run, and we can see down there in the lower left the flow that we'd expect, that before charge and then the flow that happens afterwards. And works. What's wrong with it?
Nothing, it's beautiful.
Okay, Meetup over. let's go to the doctrine of useful objects real quick. So it says an object must be useful immediately upon instantiation of the object. No dependencies of an object should ever be allowed to be uninitialized. If any use of an object's dependencies results in a nil reference exception, then the object is not useful. Furthermore, there is some breakdown here. Doesn't have any logic in its initializer other than assigning the value of initializer parameters to the object's instance variables. So we wouldn't want to construct things inside of an initializer. Formalizes the difference between initializer arguments and setters in the circumstances when one is used rather than other. Doesn't require a foreign mechanism outside of the class's own namespace to initialize it and its dependencies. Doesn't invite the passing of nils or dummy values to its initializer for purposes of setting up the object for testing. Doesn't rely on test doubles, stubs, to disengage dependencies that would cause undesirable side effects while exercising or otherwise testing it. Doesn't rely on test doubles, mocks, or spies to be used to inspect an object's execution path. Now that you've heard those and have them perfectly memorized and can recite them from memory,
So can you do that one more time?
what are some problems we have with this object? The structure here. Let's talk testing. If you were to test, do you want to charge actual credit cards? No. So how would you not charge actual credit cards with this?
Or 1111111.
That is an option. So if the gateway that you're using provides dummy values, in that case though, you're still actually having to call said gateway to get a response back. So I find that suboptimal.
Yeah, it's not.
I guess you can pass in some sort of dependency to that purchase class.
We're gonna get there. As it's written here, exactly. Yeah.
It's hard code. You can't change it out for any other implementation.
Yeah. Like you could reach for an unholy mock and redefine the call method on this class to have one that doesn't actually call, but then what are you actually testing at that point? And I've seen a project where the mocks were so heavy. Like I looked at the test and then I looked at the code that ostensibly was under test. I was like, these are not the same thing. Like this will, like you could look at it, it's like that will produce an error at runtime because it's using, I forget exactly what it was, yet it passes the test. And so that's a real problem with mocks. The doctrine of useful objects gets into why mocks are not so good. The chief reason behind it is like testability, observability, if those matter, and I would contend that they do. That's a thing of the design of what you're building. That's not something to relegate to testing. Mocks are things of testing, observability, and testability are things the design that you're doing. So yeah, this one doesn't pass. It's got some problems. So we can move on. Yes, we will see dependency injection in here. Who is familiar with what dependency injection is? And of course, I can't see the raised hands online, but I guess whoever's here in the room. Okay, so a little less than half here in the room. That's good. That means this is new, and that's exciting. Who would care to offer a definition of what dependency injection is?
I can offer one. So in languages I've used before, if we depended on some sort of like logger or some other functionality that we depend on that's not like the responsibility of the current class, we would take that in like the constructor, an instance of that logger or something else. And then within that class, you can use that dependency, but you're not really like, hard coded like this. So I guess in this case, to apply that dependency, this would maybe take in some sort of charger that could charge cards.
Yeah.
Yeah.
It lets you change the behavior of what happens without having to make a code change to the thing receiving it. Yeah. This can be implemented in so many different ways. Some of them very complicated. The document calls out specifically IOC containers, inversion of control containers. I like to define it as just passing things the stuff they need to do their job. It's really not any more complicated than that. So what you described, that's going to be our second approach here. So to save a little time, you know what I'm gonna do? I'm not gonna, I'll do it, 1 second. Let me copy, no, let me do it up here in your tree, because that will give us another benefit. So if I copy you to 0, pass in, what do we get? No, that's not what I want to do. Yeah, go ahead and delete that one. I'll just do it down here in bash. So dash r, lib 01, hard-coded, and take that to the pass in. Great. So now if I open lib 02, pass in, charge, didn't work. Not happy about that. That's fine. I'll just, I'm trying to save everyone the time of me typing this every single time. But I'm disappointed that that didn't work. Let me grab all of this again.
Maybe forcing CD minus R could help.
Can you do that?
Yeah, maybe.
Let me see if I do anything. I did this literally the same thing again. Oh wait, I have a better idea than what I did before. What if I did star and pass them in?
No, you don't want the target.
Right. Sorry.
You remove the 0.
The slash.
Oh, thank you. Sorry. It is like,
It's hard to do.
this is not representative. B live 02 pass in charge. There we go. 02 pass in purchase. There we go. All right. So that's my starting point. And why is that horizontal line there?
I was gonna ask you, because I did.
Okay, I'm sorry. Take 2. Does anybody have any good hold music in the meantime?
Scott plays the song.
I had an instrument maybe.
All right, so we're gonna now pass it in as an initializer parameter. So in Ruby, when you make a new object, if you want to call something when that happens, that is the initialize method that you put in a class. So we'll just take that and assign it. And then down here in the call, really important, we will ditch the construction there and use the instance parameter. And we'll change this number so that we know we actually are running the correct file. Nothing needs to change here except in my notes I have been putting the number there, but I won't this time so we don't count over on the right. Actually, no, let's make sure we're using the correct one. And then over here at the call site, we would need to somehow have access to that. We might do it by making a new charge object. And then
The hard-coded module.
I sure do. Thank you for catching that. I'll go fix that in the other files as well. So just set it up like that. Great. And then hard-coded and let it pass in. Go and then do the same thing over here. Okay, looks good. Anticipated output.
You're just loading for charge.
To all things, right?
Yeah, should work, not crash. Oh, right. And this is kind of an antiquated programming language. You have to tell it, like, give it access to files you want to use. That's weird.
Who does that?
What did you do wrong?
You need to save the middle file run forward.
See there. Uninitialized constant passing charge and run for pass in.
You're trying to run it again. I think it had the old namespace.
Oh, yes, you're right. Okay, there we go. It worked. All right. I would consider this an improvement over what we had before because now in a test scenario, we could pass in something else that doesn't actually charge the gateway. So it's an improvement, but what are the drawbacks we still have? if any, that you see?
You can
Well,
pass in the nil charge.
Pass in the nil charge, which, why don't we try that? Oops. Nil, what happens? Right, yeah,
I love that.
it's not as safe. What else?
Making the argument as a optional or
Yeah, it's not clear that it's required, it will want something there.
that
Um,
you need something.
What if you passed in a string? Obviously, some interfacing would help with that, and Ruby being dynamic, it's harder to catch that in a situation like this. I had some other notes in here, the things that I thought were a little messed up. Nil exceptions we talked about. The caller now needs to know about the dependency in this version. Not real jazzed about that. So it doesn't really formalize the difference between initializer parameters and what you put in a setter. Like how you actually charge in the purchase flow is not like, that's what I'm looking for. It's not really a characteristic of purchasing. That you're going to charge is, but the specific strategy used to charge isn't. So it kind of makes it not an appropriate initializer parameter. Whereas if you go into the Eventide code, there's a stream reader that you use to read from a particular entity stream. You pass it the stream as part of the initializer. Reading a stream makes no sense at all unless you have the particular stream that you're going to read from. So like the class makes no sense without that. And that would be the same in any given context. But the specific strategy used for charging, that's going to change between tests, between operational, between I'm just running something on my laptop. So one of the things that the doctrine would say is we want to put, Scott, this is the part that I'm less sure about, but for reading and studying, this is where I've arrived at is the initializer parameters are for things that are like absolute characteristics of what you're doing. The thing makes no sense without those parameters being a specific thing. Is that close? Not sure if you're there, Scott.
Oh, sorry. Was that a question for me?
Yeah.
To me?
The distinction between initializer parameters and what you put in a setter, was that explanation useful?
Yeah, I think I mostly followed it.
Okay.
Yeah. There's a lot of, there's a lot of factors that have to be considered ultimately. The things that go into initializer parameters, that's object state. Dependencies are a different class of object state and should be considered differently. Even though they're in Ruby, they're implemented with the exact same fundamental low-level parameters. In the bytecode of the processor, they're all implemented the exact same way. There's no differentiation between what is object state and what is dependency. But in higher order patterns, like in design patterns, that's where we start to distinguish these things. So there is not at the implementation level, well, depending on how you do it, but at the conceptual level, dependencies are fundamentally different things than object state. If I initialized, some sort of data structure, for example, that I could pass in all the primitive data. But if I pass in something that does I/O, input output, something that has like communication via the network or the file system, that's inevitably another subsystem. That's a dependency, and dependencies, unless you're in a language like Java that has stricter limitations, or C# that has also the same strict limitations, you've got no choice in those languages. You tend to just use constructor arguments. However, that's something that happened later for you Java developers out there who've used dependency injection frameworks. The initial implementation of dependency injection frameworks used setter injection. And then for some reason, it became some sort of occult belief that these things should be passed in by constructor arguments. And that's because of there's a missing piece. There's like There's dependency injection is one half of the equation. The other half of the equation is the null object pattern. Once you know the null object pattern, you can complete the full pattern. But if you only know DI, you'll probably go like, why don't I shove it into the constructors? That's what they're for. And that the answer to that is just simply, you haven't learned the null object pattern yet.
Awesome, thank you for that. Let's move to the next one. So if I take the lib 2 start and put that into lib 3, hey, first try, and great.
Held it.
Try for desktop. Thanks for letting me know that. Right now, when do not disturb is on. Not 4, we want 3, and this will be charge, and then, you know what? No, never mind. Sorry, I was thinking maybe of switching the order of the files here. All right, so in 3, we did it in 2, we did it as passing it in via the constructor. Well, what if we said, okay, well, let's make it an attribute on there. So for class purchase, we could do an adder accessor. If you are not familiar with Ruby, sweet, it's not covered up there. Doing this adder accessor charge call and passing it this symbol is going to define 2 methods on the class effectively. One called that, whose return value would just be the value of the instance variable charge, so matching the symbol name. And then it would also make one that would look roughly like this, that would set that. So it gives you a getter and a setter on there. And so just for shorthand, we do that. So it is no longer a parameter there. So we can in fact get rid of the whole initialized method. You're not going to do anything. You don't have to specify it. We will switch to that and that. And then we can now just call charge because that's now a method that the class has access to. Need to change the namespace here, or the module name, used as a namespace. So add attribute. As attribute, change the number here to 3. That's all that needs to change there. And then over here, we're not passing it in like that anymore. We're going to deliberately set charge equal to charge, and then we'll run it again.
You need to change namespaces.
Oh, thank you. Let's see. So and change that to as attribute. Boom. Okay, running this now should just work. What did I do? Didn't save here. Same file. Okay, it worked. Cool. Ta-da! All right, is this a useful object? Capital U. No, what's it lacking?
Well, if you don't set charge, then it's just gonna crash before.
Yeah, what happens if we do attribute? Anyone here ever encountered a null reference exception before? You programmed in JavaScript? I love JavaScript, I really do. Let me out myself as someone who loves JavaScript. But yeah, if you don't set it, you get a null reference exception. So merely initializing it still exposes you to null reference exceptions. Again, being in the hot seat here, I can't remember what other notes I had about this. So let me get those notes. Let's see, we're on number 3. Yeah, color still needs to know how to do the setup. It's just instead of passing it, it's assigning it. And then we did the null reference exception. Okay. I don't know. This is aesthetically, does this seem nicer than the other one?
Not much different.
Kind of a lateral transition, if you will. Folks online, I'm trying to watch if you have any hands up or anything and want to participate, so feel free. All right, so let's see, what do we do? We're gonna now add a constructor, and you might say, Ethan, we already had a constructor. We didn't. So there.
Okay.
We're gonna make a distinction between the initialize method that Ruby provides, and we'll call that the initializer. It's a nice pairing, goes together well. And then we're going to introduce a build method that we'll call a constructor. And the build method, this constructor's job is to give you an operational instance of the object. So beyond just not ever being able to give you a nil reference exception, this build is a convenience interface, as not my wording, it's in italics there, to make the normal flow of operation easier to do. If any of you read my book, in there, I used dependency injection all throughout it, but there was this one file where you had to assemble all of the collaborators and pass them in. That was a nuisance. So we're gonna do it a better way. So let me do the copy again. Nope, it's in lid. And that was 3, right? Help me not blunder here. All right, there's that. So let's open the add constructor one, lid 04 charge, and lid 0404 purchase. All right, so what do we do here? We're gonna keep the adder accessor over here, but let's do this before I forget it. As attribute, and I want to change that to add constructor. Great, and we'll do it in the other files when we go back through. I'm going to quickly change these numbers before I forget. All right, so the constructor is a class method. If you're not familiar with Ruby, a class method will seem like a static method in like C++ or something, but classes in Ruby are themselves instances of type class. So it's like an instance method on the class. It's not like, that's what it is. And we can define them inside of a class like this in a couple of ways. One of them is to put self dot in front of the method name. So that if we were going to call that method at the call site, it would look like that. We're calling it directly on the class. All right, so self.build, this thing's job is to return an operational instance. So how would we get the not yet operational instance? New. And notice we don't have to put the class name in front of it because in this method, we're in the context of the class. And so to get it operational, what would we have to do? Well, we need an instance of charge. And we would need to set that instance of charge. And then we would just return the instance. Like we're going to use
typo 9.
That is Italian.
You are Italian. So.
A little bit. Only a quarter. So consequence of doing that is the following. So here at the call site, we no longer need to know about the charge, which is nice. And then if we want to get one, we can just call build. And I need to change the namespace in here as well. Everyone believe this so far? I'm going to comment, well, no, we'll just run it. So now we need number 4.
Line number 7, is that again a build or a new?
It is a new.
For that.
That was intentional.
You're supposed to wait for it.
Yeah. So when it runs here, let me go up one there. Okay. Yeah, so the first one here works just fine. And we've cleaned up the call site. That's nice. But the second one, is this a useful object? Well, no, because we can still initialize it and crash. What other things?
We also can't test as well.
Yeah.
Go further with that.
Meaning like it's creating a new charge, right? So it's controlling what charge is. We no longer can have our tests put in some sort of substitute or something.
In this case, I would say that's not an issue with it.
It's not worse than the previous solution.
But I guess use the adder accessor, right? Is that what you're saying?
Yeah, the build is meant to give the operational version of it. So in a test, we wouldn't call build. Maybe an
We'd
interactive.
still have to assign it though, right?
Yes.
We have to create our own type thing.
Yeah.
Well, it would still be nil if you just knew it, right?
Yes, and that's why we saw the crash down.
Right,
That
that's
was
right.
okay. Whoops, that was the wrong
Well, I
button.
guess maybe with this example, if you used build and the test, you do the build and then you would assign charge after that. But I'm sure we'll get to a different version of this.
Yeah, you could do that. I would say, it's like, in coding stuff this way, I would never use build in a test.
Okay.
Because it's meant for the operational case.
You want to be careful of that kind of thing because it tries to make it completely operational when you build. So if it needs a database connection, for example, it tries to establish that database connection. And you don't want to do that in a test all the time.
Hmm.
Yeah, so just because we can use build doesn't mean we can't use new. And now here's the problem with it though, like purchase, why does purchase have the details of making a charge? If there's a class that needs to be set up, which class should know the details of that?
The class.
The class that needs setting up, right? I mean, it will publish an API, and if nobody needs data, we need to get it to it. But that's the same with any function that you call or method, because we're going to be joining programming. But yeah, the knowledge is still not quite in the right place. So let's keep going. So for add constructor, oh my gosh, there we go. And then want to send this to 5, add configure. All right. Let's come up here and do the similar dance. Let's change add. Complete it's down here.
You need to open the
You gotta
05
change the
files.
Thank you. Elib 05 purchase, elib 05 charge. There we go. Thank you. That wouldn't be good. Let's see. So add constructor, and this time we're going to add configure. All right. So we want to get the details of how to do this out of here. What was that?
I was blocking as well.
Okay. Let's add a method to the instance called configure. And the motivation here is that an instance of purchase should know how to configure itself and get itself operational. And that will be the same for charge. And so what we're going to say is, hey, charge class, you know how to make yourself, you know how to get yourself ready to go. So we're going to delegate that to you because that's your business, not mine. So I'm going to tell you to do that and then assign yourself to me. That's what the self is for. And I'd like you to do that on my charge property. Why the charge property? We could call it whatever we wanted. But since that is a name that makes sense for something that charges, that's what we'll say. And then so our build will change. I'm going to type this, and then if someone who is more familiar with Ruby wants to explain it so that I'm talking less, which is good for the group, we're going to change it to this. Anybody know what tap does?
Sort of.
Here's the sort of version.
So like when you do the new dot tap, it allows you to tap into that new method and do something before it returns.
Yeah. So the instance that gets passed to your block is what the raw return from new would be. And you can call things on it, set things on it, but the overall thing doesn't return until that loop is done. So what we're going to do is we're going to instantiate our new instance and then tell it to configure itself. And how does it tell itself to configure? By telling its collaborator to configure itself and put it on this object. So let's change those to 5s. We will do the namespace change here. Now this one we will have to change the charge class. So it needs to have this self.configure. Who am I configuring this onto? Where would they like me to store it? This part is of course optional. You could just say, like, if I'm going to configure myself, it's going to be at this name or else. But it's not hard to not make it that way. So how would this thing do it? Well, it would need an operational instance of itself. How would it get one?
Same way.
It would build one. We were following the same pattern. And then once it has it, all we need to do is say, hey, receiver, I'm going to send you a message here using your adder name, and I'm going to interpolate that equals in there. That equals is really important because we actually want to set this. What value do we want to set? Well, the instance we just built. And then we'll need to fill out the def self.build, very easy, no collaborators. So it just makes a new instance of itself. And then we change the number. This is where it starts, like there are wires going here. So I'm sure somebody in the room has a question about that. Maybe your cousin has a question about it. And you'd like to ask for your cousin so your cousin doesn't feel embarrassed.
I think that public send thing really threw me for a loop the first time I saw it, so I don't know if anyone else is first time, but that was like, what the heck is that?
That's how you get around visibility of things. No, just kidding. Don't get around things, follow them. Public send is a method defined on every Ruby object because it's on the object base class. And what it's saying is method calls in Ruby are actually sending messages to the object. It is a shorthand. So if I call receiver.charge equals, this is shorthand for that. This is nice because the name of the method can be dynamic, whereas I can't interpolate the chart or the adder name that we received into that. So object-oriented programming is about message passing. Like talk to Alan Kay, that's what he'll say. If you work with Eventide, what's it all about? Message passing. So it's like the same thing but distributed. So that's what we're doing. We're just invoking that setter that the adder accessor defined. And then the right hand of that assignment becomes the method that we're sending. If it were a multi-parameter method, then you just, first you would learn to type. And once you had done that, you could just type in those arguments as additional arguments to the public send method.
It's kind of optional though to use. Like I see what you're doing, Ethan, in representing this pattern that is seen frequently, but unless the name of the attribute that the dependent object, whatever the dependent object is going to name that attribute, like if it's always named charge. Yeah, you don't really need to have provide the flexibility of changing the attribute name.
Yeah, in which case it would just look like that. And then over here,
if you're providing providing code for other people though, if you're providing libraries and you need to extend a little bit of flexibility because it's very possible that your presumptions or my presumptions about what an object has to be named or could be named, like let's say you have let's say you have two of those on one object. There's two instances of charge, then you're going to have to assign it to a different attribute with a different name. So usually the more general purpose or the more toolkit or frameworky the object that you're building, the dependency you're building, the more likely you're going to want to provide some ability to override with the attribute, with the receiving attribute is going to be named. Otherwise, just disregard it, and you probably can deal with that as if it's in your own code, you can deal with it on an ad hoc basis. Like if you find oh, here's a dependency and it doesn't have the ability to have it be assigned to an attribute other than the name charge, then you can just go ahead and change the code because it's your code. If it was public open source code though, and you couldn't change it, then you'd really hope that the developer provided some of the facility to have that flexibility.
Right on.
Otherwise, it might just be a complicating factor to communicate the pattern, to teach the pattern.
That's good. Yeah, so we call build on it. It configures itself. It does so by telling charge to configure itself and place itself on us. And we can proceed with the non-parameterized adder name version of it. So when we run this, What do we expect?
I mean, we still have the new problem.
Yeah. Oh, what happened? Uninitialized constant add constructor.
We need to change,
Did I not
Save the left file.
Every time, okay, yes, the first one works again, and the second one still fails because we are not protected against null exceptions. And then what else is wrong with it? It's all the same things, but also like there's some internal detail. Right, this is the thing that's good about it, why it's better. Now, if some internal detail of how charge needs to be configured happened, purchase is no longer affected by that, unless it like needs new configuration data, in which case you change the public API, expect other things to change. That's just the name of the game. But if an internal detail changed, we've now shielded purchase from that change. Nothing else needs to know about it. That's just good encapsulation.
Certainly, somebody should have an objection to the self-configure method and the use of it on line 14 in that far right-hand column. I'd imagine somebody's got to be sitting there thinking, why not just instantiate the thing and assign it to, this classes? Like, why not in the build method not just say, self.charge equals charge.build, rather than like, why is charge assigning an instance of itself to something else?
That is a good question.
And the name of that, like on the there's a very small tech. The name of that technique on line 14 on the far right hand column is called double dispatch. The reason for it is encapsulation. Ethan just mentioned encapsulation. The charge class itself has responsibility. Think of it this way: the charge class has the responsibility to understand how to construct itself. Nothing else does. The class does. The charge class has that knowledge. So the charge class may make different decisions about how construction and assignment of itself as a dependency, how that will happen based on inputs sent to it. So that configuration is also being encapsulated. It's rare. It's very rare, but it can happen. It does happen. And in terms of having a uniform set of protocols and rules across an entire code base and eliminating special variation, we can just resort to the double dispatch and pass the object in. It's basically charge.configure. You're passing self to the charge class and telling charge, you know how to do this stuff. You go ahead and do it. It's your responsibility. You figure out all the things that you need to figure out. And then just when you're done with that, assign the results to me. And the protocol there is that purchase class promises to implement a method named charge, and that protocol is respected. That's the stickiest part of the intellectual hurdle around this pattern. And ostensibly, if you find it incredibly objectionable, you can also ignore it. Most of the stuff in here you can ignore. Actually, I build code just like this, but you can ignore a lot of it. The most important thing is that dependencies should never be nil. Dependencies should be substitutable, and dependencies should have a default value.
May not add much, but the double dispatch technique is a realization of the adage "tell, don't ask."
Yeah.
So you're telling charge to assign it to you, which in charge in the next step after you tell charge then tells you what the instance is. So it's tell all the way down.
Thank you, guys. So our
Aaron
next-
Aaron quickly glossed over that term tell, don't ask. I don't know if that was heard or not, if it was in one ear or out the other, if it was spoken too fast, but it deserves repetition. Tell, don't ask. That is an absolute fundament of software design, whether it's OO systems or distributed systems or web systems or autonomous component systems. If it's not familiar, take a look it up. It is tell, don't ask is the heuristic that gets you to encapsulation. Without it, there's no encapsulation, and without encapsulation, you have a lot more expensive work to do. Like your day-to-day job is going to be a lot more frustrating and expensive, and not in a way that makes you money, just in a way that spends money.
I guess
Unless you're a consultant.
Yeah, well, even then, you'll lose points in your speed, you know. Yeah.
I was just gonna say, one objection I would have is it kind of puts charge responsible for where it's gonna be stored on something else. It kind of just feels a little weird.
Yeah,
Instead of-
but great. That's a perfect reflection. But consider that charge is responsible for its protocols and the protocols of things that interact with it. Like I'm sure you've built, well, I don't know, I'm not sure, but many people have built HTTP APIs. The Twitter HTTP API, the Twitter web services, they are responsible for dictating the protocols of interaction.
Mhm.
Same thing, same. It's encapsulation. You're seeing things that are universal principles of software development or software design that are not often reflected in Ruby systems because we're often, using toolkits like Rails and using ORM. Once you get into the OO world, you should see very little difference between objects and services or microservices or components for that matter. All these principles should be reflected top to bottom because they're kind of like the laws of physics of maintainable software design. So yeah, it is. It's great that it seems strange because it gives a point of conversation to talk about. Because my challenge to that would be like the reason that seems strange more has to do with social factors, with human factors in the Ruby world, rather than software design factors.
Yeah, I guess just one more point on that. For me, it seems like it's a little odd that if purchase wants to have two instances of this, we would need to change charge so that it would take that attribute name, where if this was just charge.configure and it didn't take a self, it can just return a charge, and then purchase can decide, if it wants one instance, an array of instances, or whatever. But I'll keep my mind open.
No, and it's real subtle, but it really comes down to tell, don't ask, or it comes down to another quality where it's really just about encapsulation. It's about there's so many things that I can reference that explain it, but if you kind of if you know what uniform access principle is, this would be a non-issue. If you have heard or speak in terms of pull and push, or tell, don't ask, tell is a push, ask is a pull. We try to do as much as we can to not pull anything from an object. Now, ORM completely flushes that down the toilet and violates all the rules. And that's why I say ORM is not to be considered a guiding light in terms of learning OO, because we have to violate everything that's good and holy about OO when we do ORM. The reason for that is ORM is about data. Objects are about receiving messages. That means in Ruby invoking methods, but receiving messages is the way it's conceived. That's why you have the method .public send. Every method call is a message send in Ruby. So, in the spirit of the design principles and architectural principles, you tell something to do something else. You tell an object to do something on your behalf. You don't pull things off of it. So the more we can optimize for push, for tell, universally across an entire code base, no exceptions, the more that becomes the foundation, the easier the maintainability, the easier your job gets, especially as the system gets past the first couple months of development, and then you've got a lot of code to deal with. If you want to keep that productivity high, the only answer is encapsulation. Here, the only answer is to not have things entangled with other things. And when you look up tell, don't ask, you'll see that it's entirely, they're going to mention things like coupling, loose coupling. It's all just about entanglement. It's about not mixing the plumbing with the electricity. And when you go to an object and you take things from it, you call its attributes, you pull its data. That's a more pernicious form of coupling that causes much more expensive cost of change over time. So this use of configure, the double dispatch, is really just a respect of the tell don't ask heuristic. But it is really picky. Like, it's totally really picky, and you're totally right. If you had two instances of it, the object itself knows it's got two instances of it. It knows what its own attribute names are. It could just instantiate those things and assign them to its own attributes, and that would totally be workable as well. It's just, once you get kind of like, once your perspective is set on respecting encapsulation, period, and not accepting exceptions to the design rules, this is the logical conclusion.
Okay, appreciate that.
That's good stuff. I've already done the file copying for this one, so but let's talk. Have we achieved the useful objects goal?
I think we still have our nail problem, right?
Yeah. Oh, right, we're not there yet. Yeah, we still have the nil problem. All right, so I'm calling this step add discount dependency, and that naming will become clear in this minute. Add discount, meaning it's a lousier version of what is to come. So what we could do, I'm just going to put some code in here real quick. Mimic is a library that is part of the Eventide project, although it would be useful outside of autonomous components. It implements the null object pattern. I'm just going to assume that someone is not familiar with the null object pattern and just say it. A null object is one that whatever you call on it, it just returns nil. In Ruby, it would be nil. In other languages, it would be null. But there are some different varieties, and then there's weak null objects and strict null objects. A weak null object just returns null whatever you call on it. A strict null object is going to conform to the interface of some object that you give to it. And we'll give you a Ruby method missing errors if you call a method that isn't actually on the thing that you're mimicking. And this is where we're finally going to achieve a useful object. So to do that, let me see. I moved some things around. Right, we're going to get rid of the adder accessor here. And build. Why does this look different? I'm sorry, it's looking different. Right, we're going to keep this how it is. We're going to add some more instance methods here. Since we got rid of the adder accessor, we have to just do it ourselves for now, because we want to show what's actually going on. So we'll do charge equal as well. And then this will just return charge. No, it won't, just kidding. In charge, the thing we're trying to prevent is a nil reference. So if the charge is currently nil, we're going to return one of these null objects. And we're going to do that by making a mimic. And we'll pass in charge. And what that's going to do is going to make a null object that only responds to the methods that charge defines. Otherwise, we'll go ahead and return charge, or actually let me do it like this. Style preference, the other way would have worked too. So does that make sense? So if you haven't set it yet, I'm gonna give you a null object. If you have set it, I'll give you what you set it as. Come down here, change the number over here. Change the number, nothing needs to change in that class.
Module.
The module, there's something that needs to change.
Did it get saved?
Did it save? No, thanks for calling that up. All right, so now, what output do we expect?
Gee, good.
Two working, but the second one won't put anything for charge.
We need Ruby.
Why do I keep typing? Did that while I was writing this? Isn't it? No, gotta give a file run, son. Cannot load such file mimic indeed because there is a like that, and I made as a creature a habit relative. Got to get it into the load path, so I have to go up. I have this init file. That doesn't matter. All it does is make mimic available. There we go. So in the one that we use the constructor on, the operational version, we see the operational result. But in the one where we just initialized it, we don't see the operational result because we're using the null object and not the actual charge. So we can't get a nil ref. I mean, we could take the constructed one and set the dependency to nil explicitly. Do that, that's on you. That's not the object's fault. That's the operator's fault. So yeah, now we can't get nil references. We won't actually charge cards. So if you code it wrong in the operational setting, you won't see cards getting charged, but you won't crash anymore either. And that's a win. But isn't it kind of sucky to have to type all of that? And this is actually a dumb version of what we're going to do next, just to kind of give the gist of what it's actually doing. So let's do a copy one more time here. What's going on? Because why is it so hard to type in front of people?
It really is. It's impossible.
Just how it goes.
Anyone solves that like $1 billion startup idea right there if you can solve that problem. All right, so what if we could clean this up and make it less yucky? We can do that. So instead of requiring mimic, let's pull in dependency, which is also an Eventide project gem that would have use outside of the Eventide project. To our class here, we need to give ourselves access to that by including the dependency class, which is defined by the dependency gem there, onto our class. That's not even close. Dependency. There we go. Thank you. I'd like to say like that's just an affectation to make me more relatable when I'm presenting. It isn't. It's just I typed the wrong thing. We're going to get access or use it by calling the dependency method. And this charge here matches the charge here because we're saying within our class we want to call this dependency charge, and we would like it to conform to the interface of the charge class. The actual implementation of the dependency gem, it does more than what you saw here, but that's the gist of what matters as the caller, hopefully. That's in effect what it's doing. So we keep build, we keep configure, we're not changing any of that. Nothing else to change except we did all the rename spacing here. No, we didn't.
We haven't done it on the other one either.
Wait, we're on discount dependency. Yeah, that's right. That's
We're
right.
on add dependency.
Yeah.
Module.
Oh, right. Yeah, definitely. I add discount dependency, that should become add dependency, thank you. And we save the files after we make changes to them. One more time. No, that didn't save, why didn't that save? Probably I hit the wrong button. And then let's run it. And it should work. There we can see it worked, same result, we get the operational in the first one, we don't in the second, but it reads nicer in the class. Like, I'm not opposed to boilerplate, we talked about that last time. Typing is rarely the bottleneck when you're trying to get stuff out the door. But everyone get what that step did? There's a gem that encapsulates that pattern for us. And it's the one that's going to do the mimic or not, depending on whether or not we set it. So move on to the second to last one that we have. And to do that, let's copy 7. The penultimate, that's right. Which doesn't just mean like the really ultimate one. Which you see misused like that sometimes out in the wild. It's not just the ultimate one, it's the penultimate one. Live 08. Hard, there we go. All right, so now this step is called cleanup because there's just a few things we can do to make the code look a little nicer. This is all functioning. If you put this in your projects, you would experience an increase in cohesion and encapsulation. But if we can also make the code nicer to work with, why not do that? So where are we getting at? Here at the call site, like we have these 2 lines where we build it and then we invoke it. If we're not going to retain this object in the long run, like why go to the trouble of stuffing it into a variable? Wouldn't it be nice if we could just be like, this one will be called cleanup, purchase, do your thing.
You need to have purchase in front of it.
Yes. Yeah. Because we're telling the class purchase, telling the class now, I don't even want to be bothered to store an instance of you in a local variable. Class, you do one thing, do it.
I just meant like purchase in front of cleanup.
Yeah, we need to kill that off.
Oh, I thought you meant this one. Yeah, no, you're right. We tell it to look like that, and I'll just go ahead and get rid of this one at this point. Okay. So how would we do that? How do I get a method on something that I can invoke that way?
Self.call.
Exactly, yeah. We can put a call right on the class itself. And what would it need to do? Exactly. We need an instance of it, and then we would invoke said instance. And that's it. I put some other things in here. In my notes, I have an instance level configure for charge and stuff in case like someone wanted to, oh, sorry, put a self.configure on purchase in case purchase was the dependency for something else, but we don't actually need it in where we are with this right now, so I'm going to ignore that. You could extrapolate that from what we have here so far. And this should run. No, it shouldn't, because I didn't change this. There we go. Now I think it will run. Great, cleanup and run. Okay, didn't.
Cleanup is capital U.
It sure is.
The other one is also.
How to do it in the notes, not that it matters. Yeah, we can do it this way. It's 2 words though, isn't it? Come on. Don't be sloppy. Especially in the cleanup. But I am in the directory name, my bad. Cool, it worked. And this, if you work with Eventide in particular, you'll see things happen. This is really cool because by default, it's going to just make a null object But in a test scenario in particular, wouldn't knowing things about what call on that object be useful? And wouldn't it be neat if there was a way you could just say, hey, here is something other than a null object to use if someone declares me as a dependency and doesn't get me constructed. And this comes by virtue of the dependency thing. So when I said like dependency is better than my little if else there, here's one of the things that's better about it. So I should probably do the copy. Sorry, all that great build up and then you have to wait for this. 0.9 substitute. You can define substitutes, which at a first glance, you're going to say, I'm predicting that at least one person will say, the heck is the difference between that and a mock? And you're going to say heck because, you know, we're in polite company. Some of this is just filler to cover the fact that I'm typing stuff. Substitute. There we go. All right. So this one doesn't need anything because we're not going to substitute on the purchase class itself. It's the charge class where we're going to demonstrate this here. Substitute. And then for this one instead, we're going to want to get a purchase and do a substitute purchase new, and then invoke that because we don't want the operational one. So right here in charge, we are just going to come down to the bottom. Now in actual projects, like in Eventide, that's that good? That you don't have to put it in the same file, obviously, and there would be good reasons not to, just for code organization. But if your thing that you pass into dependency here, if your class has a substitute module with a module method on there called build, it will call that to build the inert dependency rather than using the null object. And so I'm going to do that like this by just putting the substitute class right down here. It's going to follow the same format as everything else, and it will have a endo. It'll substitute charged. All right, so I didn't typo anything there. What we see there, notice it used the substitute now. Where does that rock? Those of you who have done some Eventide coding, if you've seen the way that the tests are done, let me come up to the account component here. Come to automated, handle commands, open, for example, and append. You'll notice in the test, setup or assemble, actuate, and then we're going to assert things. We get the right dependency of the handler. Because we never constructed the handler, we just made a new one, we get the substitute for the handler, not the actual handler. And that, let me open it again. We use it down here, for instance, we want to ask the writer, was the opened command written and was it written to the appropriate string? Well, where the heck did that method come from? That came from message, no, it's in messaging. Let me find that real quick. Wait, messaging. Did I not? Oh, that might just be in the browser. Eventide project messaging. And hopefully, here it is. Let me find it real quick. Right, substitute. So here within one of the modules in Eventide, this is the one that the handlers use to do their writing. It defines a substitute with a number of, well, what it does is it sets up runtime telemetry So as things are being called on there, it's keeping a record of what was called. And you can then ask it questions after it's run in your test, make sure it was the right number of messages written, were they written to the correct string, was it the right type, etc. So very useful in tests there. There might be some other uses of doing the substitutes, but it's particularly useful there. And to the objection, that sounds a lot like a spy, perhaps, but maybe in like the functionality, but again, that substitute isn't the thing of the test, that's the thing of the design. When I was writing the charge class here, I, as the author of the code, wrote this. It's a thing of the design of the object, not a thing that I just slam on in test mode.
Yeah, I'll add that the design of the writer is to record that telemetry. It just so happens that the substitute uses that design to fulfill those extra requirements.
That's a good point. The telemetry is happening anyway.
Right.
Yeah. So last thing then, and thanks for bearing with this, everybody. So all that stuff, none of that yet, aside from the last, like showing the specific example of the substitute, none of that is Eventide specific. I think that's good OO, and particularly the insistence on objects being doers of things. Scott, you wrote a blog post once that the gist of it was the difference between functional programming and proper OO is how you want to form your closures. Because the instances here, we just call one method on them. We call on them, which looks a heck of a lot like just syntactically, there's a dot between the parentheses and the thing we're calling.
Yeah. The Lambda the Ultimate blog many years ago once had the line, and I've never been able to find it again, even by searching the Internet Archive. And Lambda the Ultimate was one of those people who was like, he was one of the change agents that started turning people on to the world of functional programming, when it was all Java and C# and no one really considered FP as anything more than an interesting academic exercise. Obviously now it's mainstream, but at the time in his explanations of this stuff, he was saying that objects are just closures, or an object is just a poor implementation of a closure, and ultimately understanding that a closure is just a scope of memory. That's all an object is, and that's all an object is ever should be. When an object is at its best, it's just enclosed state or encapsulated state, and some behavior that works on that state. And ideally, unless it's a dependency, its life cycle is very quick. It's one and done, and then it's garbage collected and moved on. Unless it's a dependency, which is a different story entirely. Dependencies live longer typically than straight old single behavior objects. If you think of objects as closures, you're getting close to the epiphany. Or if you already know that objects are closures, I would say you're already there. And when you keep going back to this, when you stand in that position and turn around and look behind you to where you've come from and see ORM, you'll realize that ORM stuff, that's a mutant. That doesn't comport with OO at all. And yet we should still use it because it's useful. ORM, I mean. Sorry that I went along with it.
The other thing to, like in school or in OO programming books, you're typically taught like a light bulb as your first object, right? It has an on and an off, which doesn't comport to the types of behavior encapsulating objects that Scott's referring to. But state machines are another example of a perfectly valid construct that are useful in OO languages and can be modeled. The interesting thing is that in a language like Elixir, which though is a functional language, is considered one of the more OO languages that there are, the actual it's kind of there's like an actor model type of thing, and those actors themselves become the objects, and you actually send messages to them, and they maintain their own state by way of the same way that you would do a reducer in Ruby or in JavaScript. And so it's actually this weird combination of functional, because you're just taking data in, data out. It's just that one of those pieces of data was your previous state, which is the same as how objects work. So it's just that the way you access your previous state, instead of it being passed in, you access it via this, or if you're in Python, it's both. So there's just different ways those are two very valid types of objects in Ruby in my experience.
Something that Aaron said about state machine made me think of another thing that should be, it's kind of outside the scope of dependencies and therefore useful objects. But when we talked about initializer arguments, that state that goes into initializer argument, when you call new and you pass state in there, for the vast majority of times, that state should never be mutated during the life of an object, unless that object is an exception to the rule, and that exception is a state machine. But object state should be set during the initializer most of the time and never need to change. If you're finding yourself in some method just changing object state, and you're not implementing a state machine, that should be seen as a mistake, and it should be dealt with as a mistake. Except when you're in ORM, because that's a different thing. Because ORM just doesn't follow the rules. And ORM, basically, those are data structures. ORM is data structures. That's it. When you're dealing with data structures, you're no longer in the world of objects. It's just that you're in an object-oriented language. And the only tool you're given in an object-oriented language to deal with data is objects. So you futz the objects and make them be data structures. And we're okay with that. We accept that. That's just the nature of the beast. So it's hybrid, not necessarily the way that like Elixir is hybrid, or the way that Scala is hybrid. But you'll see hybridizations of things because there is just no way to have a purism in a programming language, because the moment you have external input and external output, all the nice, clean, pure things start to fall apart. So we just have good conventions and consistencies around dealing with that stuff. And one of those things is, watch out for state in an object that's changing. That should be seen as an oddity. It's not prohibited, but it should. It's not that it raises yellow flags. It's just that anytime you're doing that, it demands that it gets extra scrutiny, unless it's a state machine.
Awesome, thank you guys. So last thing real quick here, where would you encounter this in Eventide code? Obviously, if you work in the Eventide framework's code bases itself, you'll see it, but primarily probably encounter it here in a handler class. And so this handler declares 3 dependencies, 4 actually. This log dependency basically gives you the effect of having included logs somehow and doing that. It also gives you access to the dependency method that's called there. So write is how we're going to write messages. Dependency injection you would only use with stateful things, like it wouldn't make sense to dependency inject a pure function. I think that would be kind of weird. The system clock is one of those external state things. If time matters, you want to be able to control that. So that's why the clock is here. And then the store is the entity store, which is how we retrieve the entities from their event source location. I'm not going to go down that rabbit hole today, but we talked about that last week. And then, so we declare the dependencies, and then we put a configure instance method on the handler where it configures the dependencies. And the framework itself, when you are handling messages, instantiates an instance of the handler. Probably builds it under the hood, so calls build by including this, you would get a build method put on your class, and then calls your configure method, and then dispatches the message to the appropriate handler, so now your dependencies are all ready to go. So yeah, that's when you write your handler, that's what this is all about. And that is all I got.
I have a question.
Yeah.
With the configure, the self.configure and the configure have completely opposite purposes, right?
Yes.
The configure is saying, here's all the things I depend on, send myself to them and tell them to give me them, I guess. Whereas the self.configure is saying, something depends on me, it sent itself to me, I'm giving it back, I guess.
Yeah, that's a good call out. That's exactly right.
That makes a lot more sense now, actually working with the code. That they have opposite purposes, I guess.
And it's actually the case that this is the anomaly. What we're looking at here that Ethan has highlighted is the only reason this exists in this way is because we don't control the construction of the handlers. The handlers are constructed by the consumer, and this is the template method that the framework code, like messaging handle and the way that the handlers are constructed by the consumer are set up. So we don't get to define our build method. If we could define our build method, we would put those lines in our build method. But because we don't get to define our build method, because that's part of the framework gives us a template method to hook into to configure ourselves. So it's rather atypical to use this configure method in your own objects where they're not constructed by the framework. You would typically only see, at least in our code bases, you would only see the self.configure and not this one. This code would be handled inside of the build method.
Okay. I did that the opposite in all the examples that we worked through, so thank you for clarifying that.
No worries. Only did because someone brought it up.
Any other last questions here?
Yeah, and I was gonna say it's pretty rare, or it should be pretty rare, that a framework defines a class's constructor, or that a module or an abstract base class defines the constructor of the classes that implement it. It actually makes things pretty opaque. It reduces clarity. In this case, there's absolutely no way around it, because at runtime, handlers are constructed by, as Aaron said, the consumer tool, which also turns out to be a little bit of a limitation. And I think to folks who've wanted to pass data into a handler's construction from the consumer, have found that it's a bit of a limitation. So this kind of pattern where the constructor, where the factory method, the build, is in a base module, should be a rarity.
I'm good with an awkward silence of up to about 7 seconds.
It's that, yeah. It's a bunch of those things that happen because of inheritance, when inheritance is used for the wrong reasons. Here's one. If you've ever find yourself calling super, you've made a mistake, or the developer of a framework has made a mistake. That's something that should really never happen, except when you're really, really, really backed into a corner. But super is one of those things that should never be used, casually or.
Interesting.
Stuff like prepend. If you ever use modules and use prepended modules, you're kind of backed into a corner by Ruby and you just got no choice. When you've got no choice, fine. But if you ever built a base class that requires the user to call super, you blew it. That's a problem of design. That's a problem of not understanding structural design and object orientation, and it's a problem of not understanding like what inheritance is for and how to implement inheritance. Ruby is not going to stop you from doing anything wrong, but no programming language is going to enforce you to be a good designer. No brick, no 2x4, no hammer is going to require you to be a good architect or a good designer. Raw material, it's not the job of raw materials to understand the skill level of the craftsperson. These are all things that are in the language for sure, but that doesn't justify their use, except in the worst case scenario. And you know, I kind of have a really gross analogy that I kind of use sometimes where I say, you can pick your nose with a jackhammer, but that's really not the best case scenario. All brute force measures from using super all the way down to mock objects. Every brute force thing you do, and if you do it as a habit, is reducing your own and your team's productivity by a fairly drastic amount. And if you clean all of that up, if you take care of every brute force habit, every single one of them, and you bring hygiene and sanity and cleanness to your code universally, no exceptions, you'll end up being able to operate on a different level of productivity. So all of these things together, nothing, not one thing. You know, it's kind of like saying I'm going to lose weight by no longer, eating Doritos. You know, that's not enough of a whole regime. It has to be complemented with other things. For example, exercise, other dietary constraints, lifestyle changes, sleep cycle changes. I say as I sit here, probably putting on weight as we talk, but it's a reasonably good analogy. No significant health advantage or performance advantage comes from controlling one single variable. It comes from controlling all the controllable variables and moving their sliders in the direction of goodness. So, hopefully some of this stuff will leak or sneak into your code and your habits along the way. And by the way, all of the stuff that Ethan showed is a lot of it is optional. We sort of had these patterns and we just created libraries to make it easier. The dependency library was an implementation of a pattern. There's a configure library that's an implementation. There's an initializer library that we have that implements the initializers, because that was just another pattern that was standardized. But none of it requires the use of libraries and toolkits and frameworks and stuff like that. It can all just be written out long form and be just as maintainable. Boilerplate is not going to have an effect on your productivity. If boilerplate is having an effect on your productivity, then your productivity is already slow that it probably doesn't matter very much. So if you're worried about boilerplate, I would caution that you're worried about absolutely the wrong things. The things that really change the level of productivity are not going to be related to boilerplate. So if you've got that, worry in your mind, then I would say just set it aside for a while and do an experiment in actually measuring or observing your productivity in the presence of boilerplate. Because it's not about the quantity of code you had. It's not about saving code. It's not about reuse. It's about the quality of code. And quality of code is only ever defined by design principles, measurable design principles. And that's it. If productivity, that level of productivity is vastly superior to anything you can save with boilerplate or dry or the wrong use of dry. Oh my gosh, that's a whole other conversation. Ethan, I should probably be stopped right now.
Yeah. Okay, on that note, let's close it. And for those of you who are here in person, there's pizza out there. So all those lifestyle things that Scott was talking about, you can disregard them and go have some Cool. Thanks everyone online. Scott, Aaron, thanks for coming. Aaron's been a contributor on the Eventide project as well. And so it's really cool to have you guys here. Appreciate that a lot. A lot more detail that you gave. That's awesome. Thanks for making the library and have a good night, everybody.
Thanks, Ethan.
Yeah, thank you.